two are just the guys I've been looking for. I hope you can spare a little time to explain a few things about these extra duty options and trailer towing packages and vehicle load limits.
You came to the right department, Jim. But why the sudden interest in that particular kind of information?
Because more of my customers are using their cars for camping vacations and hauling trailers or boats. Now, when a customer asks a question about a car he's thinking of buying, I want to make sure I give him the right answers.
I can't think of a better reason for Charlie and me to give you our famous short course on extra duty options. Selling a customer the right car and the right options could go a long way toward avoiding handling and other operating problems that could give the owner and the service department some real headaches.
Say, it looks to me like you have a question about something in that owner's manual, Jim.
As a matter of fact, I do, Charlie. I noticed in this tire chart that the maximum vehicle capacity is 1,100 pounds for all body styles, except station wagons. And for wagons, it's 1,200 pounds. But it doesn't say how much extra load carrying capacity you get if you order oversized tires or a trailer towing package. How come?
Those extra duty options will improve handling under unusual operating conditions, but they won't increase the load carrying capacity of a passenger car, Jim. But maybe Charlie and I better explain a few things about suspension design, ride quality, handling, load carrying capacity, and safety.
Okay, Tech. To start with, Jim, many factors affect suspension design. Styling, ride, handling, load carrying capacity, and vehicle safety must be considered. That's a pretty big order. Now, statistics show that the majority of cars are driven most of the time with only a driver and one passenger. With this very light load in the car, it takes a relatively low spring rate to ensure a relatively soft ride. Relatively soft springs have a low rate and flex more easily than stiff springs. As a result, when the wheels of a car with soft springs hit a bump, they move up farther than stiffer springs would. And that's where styling gets into the act.
What does styling have to do with it?
The buying public wants low, sleek-looking cars. The lower the car, the less room there is for the wheels to move up when they hit a bump. Engineers call that room for upward wheel movement jounce space. Now, loading a car deflects the springs, and this reduces jounce space still more. That's why a fully loaded car is more apt to bottom out on a rough road than a car that's lightly loaded.
I can see how the combination of low car styling and a comfortable ride limits load carrying capacity, but since most of the extra load goes in the back seat or the trunk, why not install rear springs with more arch to them to get more jounce space and more load capacity?
Well, it's not quite that simple, Jim. Stiff springs that are cambered to make the rear of the car ride high cause some very undesirable handling and roadability problems. As a matter of fact, a lot of people don't realize how much rear springs and rear tires affect handling and roadability. Very few people understand just how rear suspension geometry, tires, and tire pressures affect steering. If they did, more of them would order heavy-duty suspension, and they'd pay more attention to tire pressure recommendations.
Do you suppose you could explain rear-end geometry and tire behavior in simple enough terms so I could understand it? I know it would help me sell more people the right options.
We can sure enough give it a good try, Jim. The rear springs of our cars are designed to be almost flat, or not cambered or arched. A relatively flat rear spring gives the car better lateral stability than a highly cambered spring. But let me explain why this is true. A flat spring resists side sway and increases lateral stability for the same reason that a jump rope that's pulled tight or flat can't be swung from side to side. If the same rope is loose so that it is cambered, it swings from side to side easily. Increasing the riding camber of the rear springs can let the rear spring and axle swing from side to side. This will have an undesirable effect on lateral stability. That's why we refuse to install any unauthorized rear springs. But that's only part of the story. The rear springs and rear suspension of our cars are designed to provide understeer. Now that simply means that on turns, the rear suspension geometry helps steer the rear of the car safely through the turn. But let me see if I can explain exactly what happens when a car goes into a curve at highway speeds. On a turn, the car body tries to roll to the outside of the turn. The extra body weight compresses the outside rear spring. This in turn affects the outside rear wheel. A side view of the rear spring and the rear wheel shows that the wheel actually moves forward as the spring is compressed. That's because the rear wheel and axle pivot around the front eye of the rear spring. You can see in this top view that as the outside rear wheel moves forward, the rear axle actually steers the rear of the car into the turn. This is very desirable from the standpoint of good handling and highway safety.
Well, the way you explained it, Charlie, even I can understand understeer. But tell me, why do arched or highly cambered rear springs upset the rear suspension apple cart? And why don't our regular heavy-duty suspension springs cause handling problems?
Let's take those two questions one at a time. When a car with highly cambered springs goes into a turn, the weight shift moves the outside rear wheel rearward instead of forward. That results in oversteer instead of understeer. With highly cambered springs, when the outside rear wheel moves rearward, the rear axle steers the rear of the car toward the outside of the curve. In effect, the rear end tries to pass the front end. That's called oversteer. Now for your second question. The heavy-duty rear springs offered as part of the heavy-duty suspension option are stiffer, but they are relatively flat. They do not change the favorable understeer geometry designed into our cars. What's more, the heavy-duty rear springs are just part of a complete engineered suspension option, which includes heavy-duty torsion bars, heavy-duty shock absorbers, and a sway bar. And that should just about bring us to wheels and tires.
The steering and suspension systems control wheel movement and direction, but it's the tires which actually determine car direction. It's impossible to overemphasize the importance of selling a customer the correct wheels and tires for the kind of driving he's going to do. The only contact a car has with the road is through the relatively small contact areas of the four tires. All directional, as well as starting and stopping control, is concentrated in these four tire contact areas. Tires also double as springs. Since tires deflect under load, they form an important part of a car's ride control. They cushion road shock and reduce the amount of shock transmitted to the rest of the car and to the passengers. However, if a tire is overloaded or underinflated, the sidewalls bulge excessively. This reduces tire life, increases rolling friction, and seriously affects handling and cornering. When a car takes a curve at highway speeds, some peculiar things happen to the shape of the tires. It's easy to visualize the sidewise distortion of a cornering front tire. What happens to the tire contact area isn't easy to visualize, but it is very important. If you had X-ray vision, you could look right through a cornering tire and wheel and see what was happening to the area of the tire in contact with the road. And remember, all directional control is concentrated in this contact area. In this illustration, notice that the front wheel center line isn't pointed in the same direction as the contact area center line. The wheel is turned more than the contact area, and it is the contact area that controls car direction. The angle between the center line of the car wheel and the center line of the contact area is called the slip angle. In other words, it's the difference between the direction the front wheels are pointed and direction the car is traveling. Remember that while we consider a rear wheel and tire going around the same curve. Rear suspension geometry and sidewise deflection of the rear tires results in slip angles at the rear tires as well as at the front tires. Ideally, the rear slip angles should be smaller than the front slip angles. Smaller slip angles at the rear help the rear end steer toward the inside of the curve. This greatly improves handling at highway speeds. If the front and rear slip angle balance is upset, it will have an adverse effect on handling and cornering. If a rear tire is underinflated or overloaded, it deflects more and the rear slip angle gets bigger. If a front tire is overinflated, the front slip angle gets smaller. I hope this explanation hasn't been too technical for you, Jim. It's the only way I know of explaining the difference of the right tires, the right tire pressure, and the problems from overloading.
Well, you've convinced me that there's a lot more to a heavy-duty option than stiff springs and big tires. As a matter of fact, I'm sure glad I asked about these extra-duty options.
And before you ask any more questions, someone better turn the record while Charlie catches his breath. There are a few more things about tires and wheels that we ought to mention before we get off the subject. The simplest way to increase the safe load carrying capacity of a tire is to increase the tire pressure within recommended limits. This inflation limit is shown on the sidewall of current production tires. The increased pressure will reduce sidewall deflection and increase tire life. However, more pressure all around isn't always the answer. In the case of station wagons, rear tires should be inflated as much as 10 pounds more than front tires. Do you know why, Jim?
That lower front tire pressure is recommended to keep the front tire slip angles bigger than the rear, right?
Right, Jim. Of course, a salesman can't be expected to tell every customer about slip angles, but he should recommend the right options and urge his customers to read and follow the tire pressure recommendations in the owner's manual.
Speaking of options, what are the advantages of bigger tires if they don't increase load capacity?
All other things being equal, bigger tires will provide better traction and handling, and they'll deliver more tire mileage. However, correct wheels and rim width are just as important as proper tire size. A rim that is too narrow for the tire will result in excessive bulging of the sidewalls. A rim of at least the minimum width recommended is required to support the tire properly.
Tires and wheels are a complete subject by themselves, Jim. You stick to the factory options, and your customers will automatically get the right size wheels.
I'll do that, Tech, and I'll recommend bigger tires for any customer who needs them. Now, how about explaining why an automatic transmission is recommended over a manual transmission for trailer towing? Some new car prospects don't agree with that.
Let's get one thing straight, Jim. There's a lot of difference between Torque Flight and some of the other automatics on the market, particularly when it comes to heavy-duty performance and operation. Torque Flight is a 3-speed transmission, and it always starts in low gear. It has an efficient torque converter that delivers the needed torque multiplication for extra-duty breakaway performance and load pulling. With Torque Flight, a relatively high-speed rear axle ratio can be used. That's because greater torque multiplication in the transmission reduces the multiplication needed in the rear axle. Since you can use a relatively high-speed axle with Torque Flight at highway speed, the engine doesn't have to wind up so fast. This is good for engine life and economy.
There's another advantage to a transmission with a torque converter. Under heavy-duty operating conditions, the entire powertrain is subjected to greater shock loads. Much of this shock is cushioned by the converter instead of being applied to the gears, clutch, and engine crankshaft. Automatic gear selection is another Torque Flight feature and benefit. In drive, the transmission automatically selects the best gear ratio for the driving condition. This lets the engine operate at the most efficient speed. Of course, for extra pulling or added engine braking, the transmission can easily be locked in a lower gear by shifting to low or into number 2 range.
As a matter of fact, Jim, the planetary gears in a Torque Flight transmission are much better suited to prolonged low gear operation than manual transmission gears.
Why is that, Tech?
In a manual transmission, the tooth contact area is relatively small, and torque reaction imposes heavy side loads on the shafts. By comparison, Torque Flight's planetary gears distribute the load over a much greater tooth contact area, and there are no side loads on the shafts in a planetary gear set. Torque Flight is the best choice for trailer towing and many other extra-duty operations. It makes sense to use the lower gear ratios for engine braking and better engine cooling.
On the subject of engines and engine cooling, anyone who's going to pull a trailer weighing as much as the car, or plans on operating his car much of the time with capacity loads, or will do a lot of driving in hilly country, should consider one of the larger engine options. When extra torque is needed, it's more economical in the long run to get it from a bigger engine instead of gear reduction in the transmission or rear axle. A small engine that's overloaded most of the time just isn't going to be economical and trouble-free. Pulling a load calls for more power, and this in turn puts more heat into the engine's cooling system. Controlling this heat calls for some extra-duty cooling options like bigger radiators, bigger cooling fans, and fan shrouds, all part of the trailer towing package. Many extra-duty cooling system options provide a fluid fan drive, 7-bladed fan, a higher fan drive ratio, and a special water pump.
You don't have to explain those options to me, Charlie. I saw your tech film on engine temperature control just a couple of weeks ago, remember?
Oh, that's right. I forgot you got in on that session. Now, since you know all about cooling options, let's talk about brakes. In stopping a vehicle, the brake drums absorb a lot of mechanical energy and convert it into heat. Unless this heat is dissipated rapidly, it will affect the brake lining and may distort the brake drums. Styling has put more body sheet metal around the wheels. This reduces airflow around the brake drums. Bigger tires, smaller wheels, and higher speeds add to the heat dissipation problem. However, disc brakes greatly reduce the heat dissipation problem. Most of the disc is exposed to the air flowing under the car. Discs get rid of heat faster than drums. Besides, disc brake shoes actually clamp the disc from both sides. The opposing action of the shoes eliminates disc distortion. This lets us apply the shoes harder and use friction material that is not easily affected by high temperatures. For maximum duty braking, it's pretty hard to beat our disc brakes with power assist.
Don't sell our drum brakes short, Charlie. For all normal driving conditions, you get a lot of safe stopping power from our standard brakes. For more severe service, our police brake option with bigger drums and linings is a good choice. Just one thing. When you sell a customer the police brake option, make sure he understands that automatic adjusters are not used with this setup. That means he should come in for periodic brake adjustment to maintain safe pedal height. Of course, police brakes or disc brakes are not enough to stop a heavy car plus a heavy trailer. Many owners will be pulling trailers as heavy as their cars or heavier. With loads like that, the trailer must have its own brakes. Be sure and warn any prospect that plans on towing a trailer that the trailer brakes must not be tied into the car's hydraulic brake system. For safety's sake, as well as comfort and convenience, recommend power steering. This is particularly important on heavier cars, cars with bigger tires, and for people who do a lot of traveling. It reduces fatigue and makes it easier to maintain control in emergency situations.
You two have done such a complete job of explaining extra-duty options that I hate to ask any questions. But what's this heavy-duty stop lamp switch and heavy-duty turn signal flasher that comes with the trailer towing option?
I'm glad you asked that, Jim. The heavy-duty stop lamp switch is simply designed to handle the extra electrical load of operating both the car's stoplights and trailer stoplights. The reason for the heavy-duty turn signal flasher is less obvious. This special flasher is actually a variable load flasher that flashes at the same rate when trailer lights are connected as it does when the car is driven without a trailer. Since a variable load flasher won't operate slower when a bulb burns out, anyone who buys a trailer towing package should be told about this and advised to check his turn signals frequently to make sure the bulbs are okay. Also, warn the owner that if a heavy-duty flasher is replaced with an ordinary flasher, the turn signals will flash too fast when connected to trailer lights, and the flasher won't last very long.
There are a couple of points I'd like to squeeze in about trailers. Although the maximum load capacity of all our cars is the same, from compacts to full-size cars, there is quite a difference in their trailer towing capacity. For example, even with approved hitch and trailer towing package, the maximum trailer weight for compacts is 2,000 pounds. For full-size cars, it's 5,000 pounds. So don't sell a customer a compact to pull a heavy house trailer. And don't forget that for the avid outdoor fan, the Sportsman is pretty hard to beat. It's a great self-contained vacation vehicle, and when equipped with a maximum duty trailer towing package, can handle a 3,500-pound trailer. And then, of course, there's a whole family of Dodge and Fargo pickups for the man or family who go in for campers and really need a truck to handle their extra-duty vehicle needs. And last but not least, don't miss the extra information in this month's reference book. You'll find a lot of additional information on trailer towing options, trailer hitches, and even some driving tips to pass on to customers who are going to tow a trailer. And now, keep up the sales and service department teamwork in your dealership. And we'll see you next month when we preview 1969 models.